I'm told I need to take the derivative of this. So when I first started it, I approached it like I would a normal derivative problem. And I said, well, y prime is equal to, and I'm going to use the power rule. So it's equal to 1/5 x minus 3 to the 4th x squared plus 1 divided by 2x plus 5 cubed. Now all that is to the negative 4/5. Now that was just taking the derivative of the outside. Now I have to take the derivative of the inside. And I look at this inside and I say, man, I got a product in the numerator, I got a quotient going on, I then have this outside and that inside, and I have this inside, and I have this outside and that inside, and I could just see this was going to turn into one big giant nightmare. So I decided to introduce logarithms in order to simplify this problem. And I'm introducing the logarithms because the properties of logarithms, and I'm going to write those down right here on the slide. These properties of logarithms enable me to turn multiplication problems into addition problems, addition problems, not division, division problems into subtraction problems, and exponential problems into multiplication problems. So let's try and see how that applies to this particular problem. The first thing I'm going to do is I'm going to erase this scary mess right here. And what I'm going to do is I'm going to take a logarithm of both sides of this equation. I'm allowed to do that. So I have the natural logarithm of y is equal to, now I can use this power rule right here of logarithms, and I'm going to change this into 1/5 ln x minus 3 to the 4th x squared plus 1 divided by 2x minus 5 cubed. And I don't have to make it to the negative 4/5 or anything. All I did was follow this property right here of logarithms, took the 1/5 as an exponent and moved it as a factor of the entire logarithm. Now you can see I have products and I have quotients, but they're all part of a logarithm. So now I can use the properties of logarithms to turn this into something a little bit more manageable. So if you'll notice here, when I have a product, I'm adding them together. And when I have a quotient, I'm subtracting the denominator from the numerator. So basically what that means is everything on top is a positive argument, and everything on bottom is a negative argument of a logarithm. So I have log y equals 1/5 times, well, ln x minus 3 to the 4th plus ln x squared plus 1 minus the denominator ln 2x minus 5. Let's write that a little bit more neatly. 2x minus 5 cubed. I'm going to do just a little bit more work on this before I start to take the derivative. So I still have natural logarithm of y equals 1/5. And I'm going to use the power rule here for this term. So it's going to be 4 ln x minus 3 plus ln x squared plus 1 minus 3 ln 2x minus 5. And maybe you can see right now how this is going to be getting a lot easier to differentiate. So my next step is going to take the derivative of both sides. So I'm going to take the derivative with respect to x of ln y is equal to, now I can take the derivative of this entire thing, but I know it's just going to pull this 1/5 right here into the front of the derivative. So I'm just going to put the 1/5 into the front, and then I'm going to take the derivative of each of these pieces separately, because they're just pluses and minuses. They're not products or quotients. So 1/5 times the derivative with respect to x of 4 ln x minus 3 plus the derivative with respect to x of x squared plus 1 minus the derivative with respect to x of 3 ln 2x minus 5. Now we're dividing and conquering. Let's see if we can't make this even better. So the derivative of my left-hand side, well, I have a logarithm of y, and I know that the derivative of a natural logarithm is 1 over the argument, which is y. And since it's y, I got to use a chain rule and call this dy dx. And that equals 1/5. Well, that's times the derivative of this. The 4 gets pulled through the derivative. So that's 4. And the derivative of the natural logarithm of x minus 3 is simply 1 over x minus 3. Now that's plus, well, the derivative of x squared plus 1 is, oh, sorry, I left out the ln there. I'm so sorry. Let's put the ln back in. I'm so sorry, I forgot that. I hope I didn't confuse you too badly. But it's 1 over x squared plus 1 times the derivative of the inside, which is 2x, minus, well, in this one here, I'm going to pull the 3 right through the derivative, and I have the derivative of the logarithm of 2x minus 5, so that's 1 over 2x minus 5 times the derivative of the inside, which is 2. So now, again, I'm kind of simplifying my algebra here. This is still 1 over y times dy dx. And now I'm going to distribute, I'm going to kind of combine these at one time. Well, I'll do it in several steps. I have 1/5 4 over x minus 3 plus, well, this is 2x over x squared plus 1 minus, well, this would be 6 over 2x minus 5. And now if I put my 1/5 into all of those, I have 1 over y times dy dx is equal to, well, that would be 4 over 5 times x minus 3 plus 2x over 5 times x squared plus 1 minus 6 over 5 times 2x minus 5. Multiply both sides by y. And I have dy to dx, the derivative of y with respect to x, is equal to y times all of this, 4 over 5x minus 3 plus 2x over 5x squared plus 1 minus 6 over 5 2x minus 5. And to just make everything with respect to x, I'm going to go back to my original problem here, where I had in the blue y is equal to that. So I'm going to get rid of the y on the right-hand side of this equation. And my final answer is going to be the derivative of y with respect to x is equal to x minus 3 to the fourth, x squared plus 1 divided by 2x plus 5 to the third, times 4 over 5x minus 3 plus 2x over 5 x squared plus 1 minus 6 over 5 2x minus 5. And that is my final answer. It looks kind of nasty, but if you take it step by step, it's not so bad. And I think it's a whole lot better than trying to use the power rule, the product rule, the quotient rule for that one big monster derivative.